Welcome to an overview of behaviorism in education, where learning is framed as a chain from stimulus to response and then to reinforcement. This visual shows how a teacher cue or classroom prompt acts as a stimulus, students produce a response, and positive or negative reinforcement shapes future behavior, ultimately guiding measurable learning outcomes and classroom routines. To understand behaviorism's roots, we trace Pavlov's associative learning, Watson's extension to human stimulus-response relationships, and Skinner's operant work with reinforcement schedules. Together, these foundations show how pairing stimuli, shaping behaviors with consequences, and systematic reinforcement created a practical framework for modifying classroom behavior and designing instructional systems. Classical conditioning is about building associations. A neutral cue becomes meaningful when repeatedly paired with a natural stimulus, producing a conditioned response. In the classroom, that means teachers can use consistent signals or prompts to evoke desired behaviors, and with proper timing and repetition, those cues become reliable triggers for participation, attention, or routines. Operant conditioning focuses on consequences that change behavior, using positive reinforcement to add rewards, negative reinforcement to remove aversive elements, and punishment to reduce undesired acts. The schedules shown affect how quickly behaviors form and how resistant they are to extinction, with variable schedules often producing higher, more persistent response rates than predictable fixed patterns. Structured lesson delivery breaks complex skills into atomized steps, shows clear models of correct responses, provides guided practice with immediate corrective feedback, and uses brisk pacing and choral responses to keep everyone engaged. This sequence reduces errors during learning, maximizes active participation, and helps students acquire skills efficiently through repeated, supported practice. Self-instructional frames offer two complementary paths: a linear sequence of small, scaffold chunks for high success rates, and branching remediation paths that adapt when mistakes occur. Both routes prioritize active student responses with instant confirmation, enabling individualized mastery by letting learners progress at their own pace while receiving targeted support when needed. Token economies translate on-task behavior into exchangeable tokens, then gradually fade tangible rewards while shifting to variable reinforcement to sustain engagement. Over time, this carefully phased approach is designed to convert external incentives into internalized academic persistence, encouraging self-directed study habits and reducing dependence on constant tangible rewards. Behavioral contracts are negotiated agreements where teacher and student define target behaviors, clear criteria, concrete rewards, and timelines. By documenting expectations and measurable goals, these contracts clarify responsibilities and make reinforcement conditional on demonstrated performance, increasing accountability while creating a collaborative structure for gradual behavior change and academic growth. Behaviorism faces well-known critiques, especially that it sidelines internal mental processes like reasoning and creativity, risks producing passive or robotic responders focused on extrinsic rewards, and raises ethical questions about manipulation. These concerns highlight potential negative impacts on learner autonomy and the erosion of long-term intrinsic motivation if reinforcement is overused. A rigid stimulus-response model struggles with transfer and higher-order thinking because simple reinforcement histories don't build the cognitive structures needed for generalization, problem-solving, and deep understanding. Teaching complex skills requires supporting reasoning and conceptual connections beyond mere repetition, so behaviorist techniques often need supplementation with cognitive approaches. Modern practice blends retained behaviorist elements, explicit modeling, repeated practice, and immediate feedback, with cognitive strategies like metacognition, self-monitoring, and social learning. This hybrid approach aims to produce observable, reliable outcomes while also fostering learner agency and deeper understanding, creating a more comprehensive, classroom-ready teaching model. Digital behaviorism uses adaptive platforms, real-time analytics, and game-like rewards to personalize practice and reinforcement at scale. Algorithms adjust difficulty and reinforcement schedules to maintain engagement, freeing teachers to focus on higher-order facilitation and complex skills while the system provides efficient, data-driven practice and immediate feedback for each learner.